Hello friends, my name is Ramsu. Today we shall discuss about topic the abstraction concept in object oriented programming or OOPS. Friend, today's topic is very interesting, especially if you have interest in programming and you want to learn about it. So let's start. First of all, I will request to please subscribe to my YouTube channel and click on the bell option as well so that my videos can reach to you, and also you can follow me on the Facebook page as well. Friend, abstract is a fundamental concept of object-oriented programming. Like we have a concept of encapsulation, inheritance, and polymorphism. So abstraction is another very important concept in object-oriented programming. Basically, abstraction refers to the process of simplifying complex system by modeling classes based on the essential properties and behaviors relevant to the problem at hand while ignoring the irrelevant details. Basically, friend, if I try to explain it in a simple words, basically when we are making projects or we are coding for a project, we have a few times we have less detail for something, for example for a class. So what you can do, you can write it down a simple structure of a class, like you know that this is a method which will be required in a class, for example. So you just mention that method and mention that whatever the class which is using this class or implementing that interface will definitely has to define this method. So it involves the creation of abstract class and interfaces that define a common structure of a set of related classes, allowing for code reusability and modularity as well. So we know, friend, that the class is basically a template which consists of methods and properties. So it basically helps you in the reusability and modularity as well. So let's deep dive into the abstract class in detail. First of all, abstract class is a class that cannot be instantiated. That means you cannot make an object of that class on its own, and it's meant to be subclassed by more concrete classes. It may contain abstract methods, which are methods without a body. Concrete subclasses must provide implementation for these abstract methods. Abstract classes can have concrete methods with implementations. These methods may be inherited by subclasses as well. Now let me give you an example here so that you can have an idea that what actually it's going on. See, this is a class shape ABC, and it has abstract method def area self pass, def display self print display shape. So this is the abstract class shape, and this is the abstract method def area. Now see here, friend, and that this is the method which doesn't have any body. It just mention here. So, okay, now we have another subclass, class circle shape, which is basically inheriting or using the shape class. Okay, it is a concrete subclass here. This is the subclass of this shape class. Now it is the constructor define initialization self dot radius, and then define def area self return 3.14. Here see, friend, this is the main class, or this is the abstract class. Okay, then this is the subclass of this shape class. Circle is the subclass of this abstract class. This has a method, abstract method of area, but it doesn't have any implementation or definition is there. But the same method of area is defined here, which mentioned that return 3.14 self multiply by self dot radius multiply by self dot radius. So see, basically what happened, that abstract class only mention that you have a area method. Okay, and the subclass, or which is basically inheriting from the main class of a shape, this class will define the area method here. Okay, now it is necessary for it because it has abstract method, so the concrete subclass must have to define the method of area here in this here. If you don't define the area in the circle class, which is basically inherited from the base class, you will definitely get an error in the compilation. Then interface. Now what is actually interface? Interface is basically, you can say, a specific type of abstraction because it's a collection of abstract methods that define contract for the behavior of a class. A class can implement one or more interfaces, ensuring that it provides the required functionality. See from here, class shape here, this is a interface. Abstract method, define area, self pass. Then class shape, concrete class implementing the interface. Here see for one thing here, that this circle is basically not the subclass of that class, it is just implementing that interface. Here again see that define area, self pass, only the method is mentioned here, the specifications are not there. In this class, which is basically implementing that interface, we have mentioned the area, then return 3.14 multiplied by self dot radius and multiplied by self dot radius. Here we are defining or basically the area method here. So this is a concept of interface here. Again see here friend, this is the interface. Shape here is the interface which has an abstract method of area which doesn't have any definition. In this circle class, which is basically implementing the interface of this shape, which basically defines the method of area here. Okay. Then friend, encapsulation. Encapsulation in abstraction is closely related to encapsulation, which involves bundling the data and methods that operate on the data into a single unit. For example, class, the internal details of how a class achieves its functionality are hidden from the outside world, and only a well-defined interface is exposed. So if you just see from here, class background, it has constructors self dot balance is equal to balance, define deposit, self dot balance plus amount, def withdraw self amount. If amount is less than self dot balance is equal to amount, else print insufficient funds. Basically friend, encapsulation means that it basically hide the data from outside the world, and processing whatever that required is, it will do the processing. Here whatever the information is necessary, only the necessary information can be provided through the interfaces. So the all the other information which is not necessary to share, it can be done internally. So that is basically the main concept of the basically concept of encapsulation here. So it is abstraction is also closely related to encapsulation as well. Here friend, we have to understand the difference between abstraction and abstraction versus implementation as well. Basically friend, abstraction helps in separating the high level abstraction of a system from its low level implementation detail. User of a class needs to be concerned with the internal working of the class. They interact with the abstraction provided by the class. Abstraction provide a modular and flexible design, and it's easier to manage complex system by breaking them into a smaller, more manageable components as well. In summary, if we talk about more detail that what is the difference between abstraction and interface, basically friend, abstraction is a high level thing, okay, and it involves creating abstract classes or interfaces to model the essential aspects of a system. Interface, on the other hand, is a specific form of abstraction that defines a contract of methods that must be implemented by classes that adhere the interfaces. Interfaces are a way to achieve a form of multiple inheritance, ensure that classes that implement them provide a specific functionality. So friend, thanks a lot for watching the video. I hope you like this video. If you like it, please share it with the friends and colleagues, and thanks a lot for watching the video.